So we have this function. The first thing they want to know is the stretching factor, and the coefficient of the trig function is the stretching factor. Okay, the bigger the number, the bigger the stretch. The smaller the number, or the closer to zero. Like a fraction. So this is the number that affects how much it's stretched or how much it's kind of condensed. So 5 is the stretching factor. Now secant, remember, is the reciprocal of cosine, right? And then here's your argument. So secant and cosine share the same base period. The period of this function is 2 pi divided by b, where b is the coefficient of x. It's the number that eventually would be multiplied to x. So in our case, b is pi over 4. So we have 2 pi divided by pi over 4. So if we're dividing a fraction, that means we need to flip and multiply. For dividing pi over 4, that means we've got to flip it and multiply it like this. And when we do that, these would cross cancel, so the period for this function is 4. Okay? To find asymptotes of the function, now note that they want asymptotes between a negative and a positive of the period, so -4 and +4. So to find those asymptotes, you want to find things that would cause a divide by 0 error. So this is our function, but we can rewrite it. H of x is the same thing as 5 over cosine pi over 4x plus 3. That's because cosine is the reciprocal of secant. So we want to set this denominator to equal to 0. We want to find out what it's going to take to make cosine of pi over 4 times x plus 3. We want to find out what it takes to make that denominator equal 0, because that would be a divide by 0 error, and that would create a vertical asymptote. So in order to find that, you could use Desmos actually. Just plug this into Desmos and then find out where it crosses the x-axis. Those are zeros. Just remember, you only want the x numbers between -4 and +4. But to do it analytically, what you want to do is think about when cosine is 0. Cosine's the x-coordinates on the unit circle, right? So cosine is 0 here, because the x-coordinate is 0. Cosine is 0 here. In other words, cosine is 0 at pi over 2. And cosine is 0 at 3 pi over 2. So that's one thing you could do, is you could set the argument. This is when it equals 0, right? So you want to find out what it takes to make the inside equal 0. So you got pi over 4 x plus 3 equals, let's start with the pi over 2. We want to find out what it takes to make the inside equal pi over 2. And if you solve that equation, you got to multiply 4 over pi to both sides, or you could use the distributive property. You're going to get, I'm running out of room here. So let's multiply both sides by 4 over pi, because that makes this cancel out, right? But we still have to multiply it over here. And when we do that, the pi's would cancel. And 4 times something over 2, that would make 2 on the left side. Sorry about the messy work here. And then subtract 3 from both sides, so you get x equals -1 when you solve that equation. So that's one of our asymptotes, x equals -1. Let me do one more and then I'll leave the rest, just in case a student gets the same exact question here. So we said we're trying to find out what it takes to make the denominator equal 0. We got cosine pi over 4 x plus 3. We want to set that into, we want to find out what it takes to make that equal 0. That way we have a vertical asymptote. That way we have that divide by 0 problem. So we want to find out when this equals 0. That means we've tried the pi over 2. Now we got to find out what it would take to make the inside equal 3 pi over 2, because cosine 3 pi over 2 would be 0. So I'm going to take the inside of cosine, it's pi over 4, x plus 3, that equals 3 pi over 2. Do the same thing, multiply both sides by the reciprocal, by 4 over pi. And when you so that would cancel out this pi over 4 here. And when you multiply this by 4 over pi, the pi's would cross cancel. You should get 6. Okay, and then if you subtract 3 from both sides, you get x equals 3. So that's another asymptote. So I think they want semicolons in Mobius. Now, that's not all the asymptotes. There's 2 more in here. Sort of, you could do the same type of work, try to find out what's going to take to make the denominator equal 0. One thing you could do is set this this side equal to negative pi over 2 and see what it comes out with. See if it's between your period. You could set it equal to negative 3 pi over 2 and solve as well and see if it comes out with something within your period. So try some values for which you know cosine equals 0. Or, like I said, the other way of doing this, kind of the quicker and not as mathy way, is just to graph this in Desmos. Find out where it crosses the x-axis, and that's where you would have vertical asymptotes, because that's where it equals 0. And so finally, to sketch the correct graph, we probably would want to know the rest of the asymptotes, but the type of graph you're going to be looking for, it's got a period of 4. We said we have a vertical asymptote at -1. So you should see a graph that gets really close but doesn't cross at -1. And then it also has a vertical asymptote at x equals 3. But again, you could use Desmos to help you graph this too.